Hi everybody, and welcome to week 5 of Social Work 110. Right now I'm looking at the overview and learning objectives, which you can find on the Canvas page for our class. Of course, this week is going to be all about normal distributions, which are very important for us because throughout the remainder of the semester, in terms of inferential statistics, there's always going to be something that has to do with normal distributions. Inferential statistics are largely based on normal distributions. So with respect to what we're trying to learn today, or rather this week, by the end of the week, what I'm hoping you're going to be able to do is recognize a normal distribution. Even just the shape of it is part of what we need to know. You're also going to need to know what the major qualities of a normal distribution are. I also would like you to know what the term skewed means, and I'd like you to be able to create from memory a normal distribution. If you're able to do these things, I think we're moving along at a good pace. Speaking of good pace, let's go ahead and move on to my view board. I'm going to tell you right now that these are not going to be the straightest lines, or they're not going to be the prettiest pictures, but I'm going to try to move through the material for you so that you get a better understanding of normal distributions. So first of all, I'm going to go ahead and start out with just a basic shape of a normal distribution. Okay. It looks like this. And a normal distribution is a set of data points in which are you ready? I'm going to go ahead and tell you this right now. Okay, the mean, okay, and I'll give you the symbol for the mean. The median, okay, we'll call the median MED, okay, and the mode, or as I'd like to call it, the mob, okay, call it the mode, okay. What do these things have in common with a normal distribution? As it turns out, they are all the same value. They're all equal, okay? So when we're talking about a normal distribution, we can actually figure out whether any set of data points are a normal distribution by simply finding the measures of central tendency. And if the measures of central tendency, or mean, median, and mode, are the same number, okay, equal, then we know we're looking at a normal distribution. Let's talk about the shape too. I kind of noticed that it's a little bit like a mound, but it goes by some other names too. In addition to being called a normal distribution, it can also be called a normal curve, or I'm going to draw a little picture here. Okay, a little bell. It can be called a bell curve. So it's supposed to be the ringing part of the bell. Okay. Anyway, so what do we know so far? This is what a normal distribution looks like. We know that we have identified a normal distribution when we look at any set of data points, and the mean, the median, and the mode are the same number. And we can also call this not only a normal distribution, but a normal curve or a bell curve. What else do we need to know about this anatomically? Well, take a look at these two ends right here. Okay. They have a special name. They're called tails, okay? Tails. I think I can rate that for you with this without being too sloppy. There we go, tails. Okay, it's like Khan Academy here, isn't it? Okay, so there's the tails. One tail, two tail, okay? So when we're talking about normal distributions and we're talking about the ends on each side, we're talking about the tails. Now, the next thing to know about normal distributions is that they can appear skewed. And what that means, and I'm going to go ahead and show you what a skewed normal distribution looks like. And it's not even a normal distribution at that point. It's a skewed distribution. Let me go ahead and show it to you by just take a moment, erasing everything here. There we go. I've erased it. All right. Okay, coming back to my pen. Okay, I'm going to go ahead and draw another number line for you. And when you see a mound that looks kind of like a normal distribution, but instead of a normal distribution, it's kind of going like this, okay? All right, we're going to call this skewed, okay? And when the values are gathered more to the right, okay, and the tail is headed to the left, we're going to call these negatively skewed. So this is going to be a negative, okay, negatively skewed. This is what our book talks about too, negatively skewed distribution. And by contrast, if I were to draw a distribution that looks like this, okay, we're going to call this positively skewed. Positively skewed. Okay, now how do I know what's what? Okay, how do I keep in mind what this is? The tail points the way. The tail points the way. All right, typically, okay, we're going to find that numbers, and I'm going to go over this in a minute, on a normal distribution to the left are going to be negative, to the right are going to be positive. In other words, the higher numbers are to the right, the lower numbers are to the left. The tail points to the direction. So when a tail is pointing to the left, we know that this is negatively skewed. When it's pointing to the right, which is where all the positive numbers are, we're going to call it positively skewed. And why? Because I'll show you why, okay? You're not going to be surprised by any of this, okay? If we're looking at a normal distribution, again, where the mean, the median, and the mode are equal, all the numbers to the right are going to be positive, okay? They're going to be positive, and all the numbers to the left are going to be considered negative, okay? So when we see a tail going to the left side, okay, we're going to be talking about negatively skewed, and we see the tail pointing to the right, okay? How's this a tail? Well, you can draw a little, here we go, here's a good idea. Okay, here's a, here, just look, a little leg there, okay, leg there, okay, a little put an ear here and a nose here, okay. So this looks like a little animal, and here's its tail. See how its tail is going this way, okay, positive. Okay, I could draw the same thing up here, but it's probably going to take too long. That's the negatively skewed, okay. So how do we know, again, we're looking at a normal distribution? The mean, the median, and the mode are all the same. If we're looking at a negatively or positively skewed, okay, the mean, the median, and the mode are all going to be off. They're all going to be off by, they're not going to be the same number. They will not be the same number when there is skewing going on. So only when we have the mean, the median, and the mode at the same number, then we can say that it is a normal distribution. Otherwise, we're looking at something that's skewed either negatively or positively, okay? Hope that makes sense to you. You can let me know if it does or it doesn't. I'm going to go ahead and take a moment and clear this out for you. Now, let's go on and, oops, let's bring that pen back. How about that? Okay, I'm going to go ahead and I'm going to say this about a normal distribution. Normal distributions have characteristics, okay? So assuming it is a normal distribution and the mean, the median, and the mode are the same, then the line in the middle, which I've referred to several times now, is called the midline. Okay, midline. I call it the midline. Some people call it the zero line. Okay, if you ever hear me in this class talking about the midline, okay, with reference to a normal distribution, you know what it is. It's the center line, and it's where the mean, the median, and the mode are all lined up. Midline. Okay, I already told you that the values to the right of the midline are considered positive. Okay, to the left. So basically when we're working with normal distributions, if we're doing things that are going this direction, okay, we're adding. I always draw this each semester, so it helps students remember. Okay, if we're going this direction, we're adding. If we're going this direction, and just to make it a little clearer for you, I'll draw a circle around this. We are subtracting, okay? Adding, going to the right, subtracting, going to the left. This is going to make a lot more sense to you as we kind of go through next week as well. But nonetheless, these are kind of the basics of normal distributions. What else did you notice about this? Well, on the left side and the right side, they look about the same. They look about the same, or at least they should. My writing's not that great, but because they look the same, it's almost like we put a mirror up here, and technically we should be able to. We should be able to put a mirror facing either direction, and it should be exactly the same. And in that way, you can say with accuracy that normal distributions are symmetrical. Okay, symmetrical. I'm just going to call this sim for now. Okay, symmetrical. Okay, so symmetrical. So the right side mirrors the left side mirrors the right side in terms of the shape and, for the most part, the values, which we're going to get to now. So hopefully you understood from this segment that there's a midline in the middle, which is where the mean, the median, and the mode are all the same value and line up. You know that if you are talking about values to the right, we're talking about positive. If you're talking values to the left, we're talking about negative. And that if we're going to be doing any operations to the right side of a normal distribution, we're adding. If we're going to be doing any operations to the left side, of a normal distribution we're subtracting, and finally, that a normal distribution is symmetrical. In other words, at the midline, it is equally distributed on each side. It is a mirror image. Okay, very good. Let me go ahead and erase this for you. There it is. Okay, and okay. Okay, now about normal distributions. Okay, normal distributions, oops, bring that pen back. Okay, normal distributions are going to be a shape that you want to burn into your head for the rest of the semester because they're not going to change. Okay, oops, this is kind of an ugly one. It's a little bit narrow, but nonetheless, let's just go with it for now. Okay. When it comes to normal distributions, and here's our midline, okay, we're going to say that the mean is the center, just like I said, the mean, the median, and the mode are the center. There's the mean. Okay, then to the right, we have what we call the standard deviations. Now, I know you learned how to do standard deviations last week, and those are all going to come back, okay? But for now, when we're just learning the shape and the anatomy of a normal distribution, okay, I'm going to tell you that we have 3 to the right and 3 to the left of the midline. So when we're talking about standard deviations, so we have standard deviations over here. Okay, this one's going to be +1. Remember how I told you all operations on the right are positive and all operations on the left are negative? Okay, +1, +3. These are static. They are fixed. They will never change. In other words, whenever we're talking about standard deviations in this class or any class you're in, you will never see like a 4th standard deviation or 2 standard deviations. We're always going to go out to 3 standard deviations. So these standard deviations are fixed in time, fixed in space. Okay, so this is a basic look at standard deviations as applied to a normal distribution. Now, standard deviations, again, I told you we created them last week. We created a standard deviation in terms of a formula. These are markings or roadmaps, and as we go along, it's going to make a lot more sense to you what these are all about. But for now, all I want you to know is that standard deviations are, because we're talking about mirror images, there are 3 to the right and there are 3 to the left of any normal distribution. So to back up, a normal distribution has a mean, a median, and a mode that are all the same number. At the ends, we have the tails. The shape is symmetrical because to the right and to the left, mirror images. Functions to the right are positive, functions to the left are negative. If the values are slanted this way or slanted that way, it's skewed, it is not a normal distribution. And that the standard deviations are fixed in time and space. In other words, whenever you hear me talking about a standard deviation in this class, whenever you hear me talking about a normal distribution in this class, the standard deviations will always be the same. +1, +2, +3, -1, -2, -3. And now here's where it gets a little tricky, but not for you guys. These are also some values that are never going to change for you, okay? Between the -1 and the +1. Between the -1 and the +1, we're going to have a certain number of values. Now, underneath the normal distribution, it's 100%. Now, that's actually a question on your participation sheet. 100% of all scores in a data set, okay, occur under the normal distribution. So this is 100% of all scores, okay? There we go. So from here to here, from tail to tail, 100%, all right? But in terms of how things break down overall in the normal distribution itself, from a -1, here we go, to a +1, okay? From here to here, there's a certain percentage of this 100%, and that percentage is never going to change. And that percentage is 68 point, the point right there, 26%. Okay, now, is this worth memorizing? I think it is. 68.26 or 26%. Okay, all right. Now what's next? Well, right here. Between the -2 and the +2, we have another percentage of all scores. Now we know from end to end it's 100%, but from the -2 to the +2, okay, 95, we'll go 0.44%. Again, thank you for your patience with my writing. And then finally, okay, -3, ugh, that's ugly, to +3, okay? What do you think this is going to be? 99 point, here's the point, 74%. Okay. There we go. That'll make that percentage sign a little bit better for you. Okay. So here are the things that qualitatively are never going to change. These are characteristics about a normal distribution that are never going to change. The midline is going to be in the middle. The midline is going to represent the mean. Okay. To the right of the mean are positive values. To the left of the mean are negative values. And the standard deviations are going to be 1, 2, 3 to the right and 1, 2, 3 to the left. Okay, positive to the right, negative to the left. We also know that 100% of all scores are underneath a normal distribution. And we also know that between -1 and +1 are 68.26% of all scores in this normal distribution. We also know that between -2 and +2, 95.44% of all scores are between these two. And between -3 and +3 standard deviations, it's 99.74%, because if we went up from tail to tail, it'd be 100%, right? Do you see how this is beginning to kind of look? All right, so that is, for now, what I'm going to leave you with respect to normal distributions, and I'm pretty sure we have covered everything we need to for that second part of your participation sheet for week 5. I don't think that anything else, I don't think I've left anything out, but just in case we need to look at it, we'll go back here and make sure that I got what we need done. Okay, let's take a look. I'm going to go over this again in class, but we'll go ahead and go down to participation sheet for week 5. We will open it up right here. And I will go ahead, there's your review, make sure you do that. Okay, normal distributions are found when all measures of central tendency are the same, okay, or equal. Because of their shape, normal distributions are known as normal curves or bell curves. Each end of a normal distribution, you know what it is, it's a tail. When values are gathered more to the right, so that the tail is going to the left, the curve is said to be skewed negatively. When values are clustered more to the left, so that the curve is said to, that the tail is pointing to the right, we say that the curve is skewed positively. And we know that, we notice that the tail points the direction. Normal distributions contain 3 standard deviations, to the right and to the left. To the midline of the midline, which is called, of the center, which is called the midline. Values to the right of the midline are positive, while values to the left are negative. Normal distributions are symmetrical, meaning that the left side is a mirror image of the right side. Values within a normal distribution present 100% of all scores. The percentages between standard deviations are fixed. They never change. They're constant, okay? So they are, the best way to put it is maybe you could say fixed or you could say static. They're consistent. They never change. And so that's going to do it for now, and we'll go over this again in class. So again, repeating what we need to repeat so that we are able to get the material. Thanks so much.